Hi, my name is Rajdeep Das and I welcome you to my demo video. I am currently from Kolkata, West Bengal and working as a trained graduate teacher in a reputed CISCE affiliated school. I also give online and offline tuitions to students of grades 6 to grade 10 from boards like CBSE, CISCE, state boards and NIOS. In my brief teaching experience of 3+ years, I have mentored hundreds of students and I have got a great response from them. For today's demo, I will be teaching mole concept from chemistry and current electricity from physics, and both these topics are from grade 10. I will be using deductive method of teaching. So the first topic for the day is mole concept. So why do we study mole concept first of all? What are the learning objectives? The learning objective of mole concept is when we have a sample given to us, we need to find out, we need to understand, we need to find how many molecules or how many units are there in that particular sample. For example, if someone asks you that, okay, if I give you say 100 grams of oxygen, tell me how many molecules are there in 100 gram of molecule and in 100 gram mass of oxygen given to you, oxygen gas given to you. So in such cases, what we will do, we will use mole concept. Okay. So what is a mole? Let us define what is a mole first. A mole is the amount of mass of a substance which will have the same units, rather I should say same number of units as the number of atoms in a C12 in 12 grams of C12 atom. Okay, in 12 grams of C12, not atom, sorry, in 12 grams of C12. So that is the 1 mole. Now 1 mole contains how many units? Avogadro number of units. What is Avogadro number of units? This is given as 6.022 10 to the power 23 number of units. Okay, this is the Avogadro number of units. Very important. We will be using this information in time to come in this lecture as this lecture develops. So before going on to understanding mole more, we have to understand two things: relative atomic mass, relative molecular mass. Okay, relative atomic mass, relative molecular mass, both are based on C12, carbon 12. Now what is carbon 12? I've like a lot of students, they say that, sir, we have heard of carbon. What is carbon 12? Let me tell you, carbon has two isotopes. One is C12 and one is C14. What happens? C12, it is abundantly found in nature. Okay, C14 is a radioactive isotopes that we use for carbon dating. Okay, it's found in all living beings. So when we take the occurrence, okay, the abundance, C12 is way higher. So that is why we can use, ideally we should use a particular substance which is abundant and do not have an isotopes. But carbon 12 has an isotope, but still we are using it because C12 is more abundant than C14. Okay, good. So let us understand what is relative atomic mass, relative molecular mass. This is the prerequisite to understanding mole concept. Okay, so let me take here the elements. So the first element, let me take hydrogen. Hydrogen is okay. So first let us define what is relative atomic mass and what is relative molecular mass. So relative atomic mass is the amount of times, is the number of times, an atom is heavier than 1/12th part of C12 atom. And what about relative molecular mass? Relative molecular mass is the number of times a molecule is heavier than C12 atom. Remember, it is 1/12th part heavier than 1/12th part of C12 atom. Okay, so this is about your relative atomic mass and relative molecular mass. For hydrogen, the relative atomic mass is 1. For relative molecular mass is 2, because in a molecule H2 we find 2 atoms, so relative molecular mass is 2. For nitrogen, relative atomic mass is 14, relative molecular mass is 28, N2. For oxygen, it is 16, relative molecular mass is 32. I'm just discussing some of the common elements. It is 35.5, and if I talk about Cl2, it is 35.5 multiplied by 2, which is 71. So this is about relative atomic mass and relative molecular mass. Now, why did I discuss this? Because the relative molecular mass, of course, the units I have to tell you, the units are atomic mass unit. Okay. So these units, say hydrogen, H2 molecule, what is the relative molecular mass? 2 atomic mass unit. Oxygen, 32 atomic mass unit, AMU, atomic mass unit. Because it is a relative scale, right? Atomic mass unit. Now this particular atomic mass units, if we are expressing in grams, then that is 1 mole. I'm repeating. The relative molecular mass of an element, when expressed in grams, that much quantity of matter of that particular substance will contain Avogadro number of molecules. Okay, so let us understand this. What do I mean by that? I mean by that is, if I take say 2 grams of hydrogen, it will have 6.022 10 to the power 23 molecules. If I take 71 grams of chlorine, this will also contain same number of molecules. So I can conclude that number of molecules I'm talking about, right? 71 grams of chlorine, number of molecules are same as 2 grams of hydrogen. Okay, so this was something very important and something which students are afraid of understanding, afraid of applying. Okay, but once they get exposure to all this, then they are a bit comfortable. That how can 71 gram of chlorine be equal to 2 gram of hydrogen, right? I'm not saying that they are equal. I am saying that the number of number of molecules in 71 gram of chlorine and the number of molecules in 2 gram of hydrogen, that is same. 2 grams can never be equal to 71 grams. But the number of molecules in 71 grams of chlorine, that is equal to number of molecules in 2 gram of hydrogen, and that is equal to 1 mole. Okay, so this is about mole concept. Let me take a small numerical here, okay, to reinforce the understanding. Say if I have a question, how many molecules in 7 gram of nitrogen? If I have a question like this, how many molecules in 7 gram of nitrogen? So what can we do here? We can find out first how many moles are there in 7 gram of nitrogen. Okay, so solution will be, let me use a different color pen. Solution is, what we know, 1 mole of nitrogen is how many grams? 28 grams, correct, 28 grams. So 1 mole of nitrogen is 28 grams. If I use the unitary method, 28 grams equals 1 mole. 1 gram equals 1 by 28 mole. And 7 grams equal 1 by 28 into 7. So it is 1 by 4 moles, or I can say 0.25 moles. Okay. Now 0.25 moles, I know in 1 mole how many molecules I will have? Avogadro number of molecules, 6.022 10 to the power 23 molecules. Now if I have 0.25 moles, then I will have how many? I will have 0.25 into 6.022 10 to the power 23 molecules, which is equal to about 1.5 into 10 to the power 23. 1.5 10 to the power 23 molecules. I hope that this small lecture, condensed lecture, has helped you understand a little more about mole concept, brought a little bit more clarity on mole concept. Okay. Now I am going to go for my second topic, which is current electricity from physics. Current electricity. In current electricity, we have to understand a few terms first. First, we will understand what is a electric current. We will understand what is potential, what is potential difference. Okay. So if I talk about electric current, what is an electric current? An electric current is the flow of charge. It's as simple as that. But for our study, we are seeing the flow of charge in a circuit, in a closed circuit. Okay, electric current is defined as the flow of charge. It can also be defined as the amount of charge moving through a cross section, okay, in unit time. Electric current is represented as I, and it's mathematically given by Q by T, where Q is the charge in coulombs and T is the time. Like for example, if I give you the values, like 3 coulomb of charge has gone through a cross section of wire in 6 seconds. So what will be the current? 3 by 6, which is 0.5 amperes. What about the potential? Now potential, we have to draw an analogy here. Potential, think about a mechanical system as in think about a daily life situation where you're dropping water on an inclined plane. Okay, we are understanding potential here. Say this is an inclined plane. If I drop water here, say water which is lavender color, I'm dropping water here. What will happen? It will flow down. Flow down. If the slope is less, it will trickle down. If the slope is more, it will rapidly flow down. Yes. Why is it flowing down? It is flowing down because this point, if I call it A, and this point, if I call it B, the gravitation potential of A is greater than gravitation potential of B. A is at a higher point, is at an elevated point. B is at a lower point. So that is why it is flowing. If both were in the same point, water would never flow. Water will stay there. So similar concept is there in the potential, electric potential also. Okay, just let me erase this. Just give me a moment. Similar concept is there in the electric potential. So what is an electric potential? Electric potential is defined, just a second. So electric potential is defined as the work done in bringing a unit positive charge from infinity to a given point. And since we are talking about electric circuit, then a given point in a circuit. But sometimes we talk about electric field also. Okay, there is no circuit there, there's a free space. So let us keep it like this, to a given point. If I'm talking about a circuit, then to a given point in a circuit. Okay, say point A. What is the potential of point A? Electric potential of point A. It is the amount of work done if I bring a unit positive charge from infinity to point A. When I'm bringing it, I'm doing some work, and that work is saved as the potential at that point. Potential on the charge at that point. And what is potential difference? Potential difference is the same thing, but here it's not from infinity. When I'm bringing a charge from one point to another. When I'm bringing a charge from one point to another. In potential difference, say I've brought a charge from point A to point B, the amount of work I have done, that becomes the difference in potential of A and B. If there is any proper difference, when I join points A and point B, current will flow. Okay, current will flow there. So this is your current electricity. In current electricity, I'd like to take one more subtopic here, that is Ohm's law. Ohm's law. Okay, we have seen that there is potential difference, there is current. What is the relation between them? The relation between them was given by Ohm. Ohm's law states that the current in any circuit, it is directly proportional to the potential applied. Okay, greater the potential applied, greater is the current. That we have seen in the analogy also, right? Greater the steeper the slope, what will happen? Rapid is the flow of water. When the slope is small, the flow is small, the rate of flow is small. Okay, good. So I is proportional to V. Now this is not a universal law. This is not a universal law. Means it is having some conditions. If those conditions are not met, then this law does not hold true. Okay, one of the major conditions, like you can say that temperature should remain constant. If temperature is constant, then this law is valid. If temperature is changing, what happens? Resistivity changes, and we have a lot of noise in our experiment. So we are not getting accurate results. Okay, so this is your Ohm's law. I'm not going deep into Ohm's law, but if I talk about the graph V versus I, the graph is a linear graph, okay, passing through the origin. As V increases, I is also increasing. The conductors which follow Ohm's law are called ohmic conductors, and the conductors which do not follow Ohm's law are called non-ohmic conductors. Okay, so that is it for today, and thank you for watching the entire demo video. I hope that you like it. Okay, have a good day. Goodbye.